Hello. In this video, we'll be talking about a system of linear inequalities in two variables. For problem 9, we have another set of inequalities. We have x plus 2y greater than 2 and x minus y less than or equal to 0. As before, I'm going to take that first inequality there and consider the equality version of it to find the boundary line. I will again do so by getting this into slope-intercept form. I will subtract x to get negative x plus 2 on the right. And then I will divide by 2 in order to get y equals negative. I'll write this as negative 1/2 of x plus 1. That way I can think about it as slope and intercept. The y-intercept on that boundary line would be at y equals positive 1. And my slope is negative 1/2. That means down 1 over 2. Down 1 and over 2. Or up 1 and back 2. This will help me draw my boundary line for the first inequality, which I will draw as dashed because we have greater than, not greater than or equal to. Just like that. Then for the second inequality, I will first, again, write it as an equality. And I'll get y by itself there. Negative y equals negative x. If I subtract x to the right, then I can divide everything by negative 1 to get y equals x. That is just the parent function, y equals x, that goes through the origin. And that one I will draw as a solid line because it is using a less than or equal to. So something like that. Then I'm going to test the point. I usually test 0, 0, but because that is included on one of our lines, I'm going to test something a little bit different. Let's test 5, 0. So I'm going to test this point here, 5, 0. If I plug that into my first inequality, I will get 5 plus 0 is greater than 2, or 5 is greater than 2. Meaning anything on that side that includes 5, 0 would be the half plane that should be shaded for the red inequality, or the first one. So that would mean everything above the red dashed line. I'll also test the same point for my second equation there. 5 and 0 would be 5 minus 0 is less than or equal to 0, or 5 is less than or equal to 0. That one is not true, meaning that I am not going to include that side for the blue inequality I have. Instead, I'm going to shade everything that would technically be above this line, so that would mean everything here. My overlapped region then, which would be the top part of this graph, is going to be the part that would satisfy both inequalities, so I'll erase these two and only shade this part right here. Let's look at one more. And in this one, we have 3 inequalities to work with. So it's going to be a bit more complex. So here we have y greater than or equal to 2x plus 2, which I'll just go ahead and start with that. And I'll think about the equality version of that to find the boundary line. This already is in slope-intercept form, so I can go ahead and graph this. Y has an intercept at 2. There's also a slope of 2, so up 2 and over 1, or down 2 and back 1. This one I will draw as a full solid line here, because this inequality is greater than or equal to. Then, I'll take this second inequality there, consider the equality version of it, which I should already be able to graph. That is a vertical line that starts at x equals negative 3. So at about here, I will have a vertical line. This one, though, will be graphed as a dashed or dotted vertical line because the inequality there is greater than. And lastly, we have a third inequality here, which again, I'll consider the equality version as y equals 2, which I should be able to graph as a horizontal line that goes through y equals 2. And yet again, this one will be graphed as a dashed line going through y equals 2. because the inequality there is a less than sign, not a less than or equal to. Then, as before, I'm going to test a point and see if that would be included in the solution set for each of these inequalities. I'm going to go ahead and test 0, 0 again, because that is a value that's not on one of these lines, and it's a pretty easy one to check. So if I try 0 and 0 for x and y in that first inequality, I will get 0 greater than or equal to 2 times 0 plus 2, or 0 greater than or equal to 2. That means the side that includes 0, 0 should not be included for that first inequality. So I'm going to shade the part above, as 0 is not greater than or equal to 2. Then I'm going to test the same thing for everything else. So let's go ahead and check the second inequality there. I'll plug in 0 for x and get 0 greater than -3. 0 is indeed greater than -3, so that means we do want the side of that blue dashed line that includes the origin. And lastly, if I check the third inequality there and I put in 0 there, I get 0 less than 2, which is also true. So that means we want the portion of this that includes everything below the green dash line. There's a lot of overlapped regions here, but there's only one part of this graph that overlaps everything. And that part of the graph would be right in the middle. The part where all three overlap here, I will shade in light green, would be right here, this little triangle-shaped region near the center. Note that this would include the values that are on the red line, but would not include the values that are on the green or blue dashed lines. That's it for today, though. I hope that helped you work with some systems of linear inequalities. Have a nice day.